I do, this is Mike Zellers, this is CISS 243. I am not going to go over the stuff that is written online. You have those resources like the syllabus, the way things are laid out, and so on. So please read this. Please read those materials. And the one of most note is that this being a blended class, there's only one in-person lecture per week. We're going to start off with one lecture per week, and it will be in person. And it will be Tuesday from 1 to 2 p.m. in BU 105. And you can either come into BU 105 and watch it. You can watch it on WebEx. The link is in Canvas. Or you can watch the recording later. I think I started recording. That's my fear. Yes, I did start recording. Then I'm going to get all the way through the class and realize I haven't started it. Anyhow, I do notice that there's two people that are here that were also in my morning class. I have apologies in advance, all right, because this class is going to look suspiciously like the first class. But I hope I'll vary it enough to make it interesting. Because we're going to talk about the same thing, that is clients and servers, and we're going to talk a little bit about, we'll probably get into Razor pages. So I just want to make sure everyone here, even those that aren't physically here, you know, recognizes and understands what is meant by client code, server code, and so on. We're actually going to focus, one thing that's different is we're going to focus on server code in this class. Not that client code will be forgotten about, but the bulk of this class is about writing server-side code. So that's where we will go. All right. We have the client. We have the internet, which I'll represent by a cloud. And then we have a server. The client connects through the internet and makes requests to the server. The server goes and responds to the client. How does a client make a request to the server? Client makes a request to the server every time you click a link. Right? When you click a link, you're making a request to a server for a specific web page. Also, if you were to type in the address into the address bar, that would also be making a request. So anytime you're clicking a link, you're making a request to the server. And that request has to follow a certain format. You can't just make any request to the server. It has to follow a certain format, and that format is called a protocol. And there's many different protocols on the web. The one we're most interested for web pages is HTTP and HTTPS. So we use that protocol to make a request, and the second part of the request then is a URL or an address. The URL identifies what web server is to get the request, all right? There's a mapping out there in your domain name servers that changes the name of a website to its IP address. Because for this to work, for the TCP/IP protocol to work, every machine has to have its own IP address. Well, people aren't going to do well remembering IP addresses. So therefore, the domain name server translates the IP, translates a name into the IP address. so that the right server gets the message. So at any rate, the server makes requests. I'm sorry, not the server makes requests. Client makes requests, which is typically going to be a protocol and other information. In our case, HTTPS and the name of URL. And the user is going to respond to it. And how does it respond to it? It responds to it in the form of a web page, typically. So, client makes a request to the internet, it gets to the proper server, the server responds, and it responds with a web page. That's a typical interaction that takes place when you're surfing the web. All right. Requests are made every time you click a link or type in an address in the search bar or the address bar, I mean. And that's what goes on. So whenever we're talking about a web server, we're talking about a system that includes hardware and software that is able to listen for requests and respond to them. This machine over here that I'm working on here, that's a machine. Is it a server? No, because it doesn't have the proper software running that is out there listening for requests, waiting requests and waiting to respond to them. My laptop, which is in my bag, that's also not a server. You can't make requests to it. Now, Learning Community College's web server is a server because you can ask for pages from LCCC's website and get them back. All right. A client is anyone that is browsing the web. So it can be you on your phone, you on a laptop. It can be a Google bot that's crawling the web and indexing all the web pages it finds. It can be a person that's calling a weather service to get the latest weather information. I don't mean a person, I mean a program, a web page that's calling that so they can incorporate on their page the local weather. You know, it can be any number of these things as the client, but the client, what distinguishes a client is it's making requests, and what distinguishes the server is that it's fulfilling requests. All right. Now, in CISS 216, we studied something called static web pages. When we use the word static web page, what do we mean? What's the word static mean? Takers, you at home, you're welcome to interject a response if you wish. It won't change, all right, is what a static web page is. I should rephrase that a tiny bit. It doesn't change unless there is like user intervention. And I don't mean user intervention, I mean developer intervention. So in other words, if you, those of you that have taken CISS 216, if you found all the pages that you had in that class and brought them up today, they would look exactly like they did when you turned them in. All right. The content would be the same, the appearance would be the same, everything about them would be the same. They wouldn't change. Now it's possible to change them, right? But you'd have to go into the code and manually go in, make the change for it. So keep this in the back of our mind. Let's keep what static pages are in the back of our mind. And let's try to figure out if we go to Google. Could this be a static page, what you're seeing now? It conceivably could be, because those links are probably the same. The Google logo is mostly the same. Every once in a while they have a special logo. The buttons are the same. Now, some of these links over here might change a little bit. So strictly speaking, this is not a static page, but it's pretty close to a static page. In other words, if we were to go back on this next week in our lecture on Tuesday, it's going to look pretty much like this. So this is a fairly static web page. So the Google front page is pretty static. All right. Now, if I go and search for something, all right, the results page. Is the results page static? In other words, if someone else was visiting this page, would it be static? Would it be the same? No. What does it depend on? It depends on a lot of factors, right? It depends, first of all, on what you typed in the box, right? We're at this page, we're at this Google search page with some other stuff at the end. If we search for ASP.net, we're on that same page, yet it looks totally different. So the one thing that can make the difference between what a page looks like one time versus another time is what we type in on forms, right? Forms, which we talked about a little bit in CISS 216, are the way in which the client can communicate information to the server. So forms allow the user to do that. They allow them to communicate to the server. So therefore, every time I put something in, different search term in, I'm going to get different results. If I put in JavaScript, CSS, whatever, I get different results. Google actually depends on a lot of other factors besides that. You mentioned the users, all right? I'll give you an example. If you have searched for certain things, all right, in the past, historically, your searches are going to be skewed in that direction. Right? I'll give you a for instance. Now, I'm not logged in as myself, so it's not going to, the results aren't reflective of my search history. But if I were to type in Don Cherry, there's two people that are roughly as famous as each other named Don Cherry. Neither one of them are like household names, but both of them sort of have a group of people that know about them, and you tend to be in one of the two. The first Don Cherry that's listed there is a hockey announcer. He's a famous hockey announcer in Canada. I don't know if he's still doing it or not, but he's a famous hockey announcer. The other one is a jazz musician, Don Cherry. They're both named Don Cherry. So if you historically have gone and searched for a lot of topics pertaining to jazz music, and you did a Google search, you would primarily get information about Don Cherry, the trumpeter. If, however, you were a hockey fan and continued to do queries that related to hockey, or probably even sports in general, you would likely get the hockey one. So that's the second way that the page changes. It changes based on what your search history is. Here's another example of how the search can change. I'm going to type in Italian restaurants. Say I'm thinking about going to dinner and I type in Italian restaurants. Notice what we get. We'll go past the ads, all right? We get Sorrento's, Olive Garden, Angelina's Pizza, the 10 best Italian restaurants in Elyria, Lorain County, Elyria, Ohio City, Tremont. All these are localized to where I'm located. How does it know where I'm located? I would say it could be, yeah, it could be GPS or IP address. For this one, it's probably the IP address. Although Google wants to know my location, it might be asking to use a GPS associated with this mission. And if I say no, it still has the IP address to figure out approximately where I am. It knows I'm somewhere by Elyria. Okay? Now, if you think about this, there's no way that static pages could be responsible for that. It's absurd to even think about it. Right? Are you going to have a static web page for every single thing that a person could possibly search for? Of course not. Doesn't even make sense. All right. People can search for anything. And that page returns a list of pages that meet that criteria. Are you going to have a different page for Italian restaurants in the Elyria area versus New York City area? No, of course not. Because, you know, you're going to have one for every community in the United States or even worldwide? No. None of those things make sense. So the web pages that we developed in CISS 216 were static pages, means they don't change unless there is intervention on the developer's part to actually change the web page. This has to be some other kind of web page, and we call the other kind of web page dynamic. All right? So dynamic web pages are pages that change based on, and you can have a laundry list of factors. Can change based on your location. Can change based on the user that's logged on. It could change based on platforms. If I did a search for word processing software on a Mac versus on a PC, I'm going to get different results. All right. How's it going to know that? All those things are either in or can be derived by that request. In other words, that request doesn't only include the URL that you're requesting. It also includes the location that you're searching for in the form of either the IP address or, well, it would ask the client your GPS. So your request probably wouldn't contain your GPS coordinates, but it would definitely return your IP address that can be used to derive your approximate location. If you're logged in, it remembers that, who you're logged in, and your request would contain that, or cookies would contain that, and so on down the line. So that's typically part of the request. The platform that you're using is part of the request. It knows what browser you're on. It knows what operating system you're on. So what's happening then is the response that the server makes to a request is the same in the respect that it's going to return an HTML document. Right? An HTML document composed of HTML, JavaScript, and CSS. What's different is the actual content of the web page. So what do you do when you write dynamic web pages? You don't write all the content. You write a template for what your web page looks like. And then you write the instructions to go and derive that information to fill the template. So in other words, whoever developed Google site and the Google result page, there's a template, right? I do a search if I search for Asian restaurants. All this stuff is the same. The Google logo that takes you back home is the same. Little speech thing, the search, the clear out, the links to maps, news, shopping, images. That is mostly the same. But the information that's filled in here is different. The other column is very similar because there could be related topics in the other column. See results about Chinese cuisine. And then there's related searches that maybe help you narrow it down if you're having a hard time finding what it is you're looking for. So your job as a web developer when you're creating dynamic pages is to not write a web page for everything, but write a template that can handle certain kinds of requests, and then write the instructions that can piece together or essentially dynamically write the web page that's a response. All right. So how many Amazon product pages are there? There's one page that can handle millions of different products, right? There's one page that can handle millions of different products. So if Amazon decides they want to include an extra link, you don't have to go into a million products, different pages, and go in and change it. You change the template that contains it. Now, so far, so good. What do you think there's more of on the web? Dynamic or static pages? I would say dynamic. Think of a site that you use. All right. Is there any personalization to it? Let's think of some sites that people commonly use, some popular websites. And let's talk about whether they're dynamic or static. Facebook, dynamic or static? Of course it's dynamic. You're going to see your friends' posts. I'm going to see my friends' posts. All right. So it depends on who's logged on. News sites, dynamic or static? Probably dynamic. Those may be, but probably not. All right. Those may be static, but probably not. Because for one thing, if you go to a news site, typically they'll show you local news as well, right? So they'll show you news from Ohio, along with the worldwide important news stories of the day, right? eBay, dynamic. It's hard to really think of a popular website that's static, all right? Because all those do is provide information to you without any customization, without anything that changes depend on who you are, where you are, what time of day you're accessing it. You go to a TV network's website, that is dynamic based on the time of day. If I were to go to HBO's website, for example, it would show me what's playing on HBO now. Versus if I go tonight at 8 o'clock, it will show me what's playing tonight at 8. All right. So it's very rare for there to be static pages. That's how websites originally were. Back in the old days when the web was first invented, that's what you had, is static pages. For the most part, until server-side languages were developed. People would call static pages brochureware, sort of, not really maliciously, but just as a description. In other words, it's just another way to have your electronic brochure, or have a electronic brochure. Instead of your company printing up things, you put it on a website and go. So maybe, well, I'll ask you, what might be an example, what might be a website that might be static? Can anyone think of a website that might be static? Or not a specific website, but describe a website that might work as a static website. Absolutely. And what about that business? What would be notable about that? Right. Right. It would be a pretty basic website that essentially just presents information and doesn't need to vary for the person. Doesn't need to vary with the time of day. Yes. No, because you can add an entry and you can change an entry immediately to Wikipedia. I'm thinking of a restaurant, a mom and pop restaurant is probably a static web page. Why? Because what do you need on a web page? You need, a description of the restaurant, the menu. Well, the menu changes, yeah, once every 6 months, maybe they'll add something or take something off the menu, but it doesn't change very frequently. So you could get by with a small restaurant or small mom and pop business of any kind. It doesn't really change stuff too often. You could have a static website for that. But most of the websites that you are going to be accessing are going to be dynamic sites. Okay. Now, so we already established that most of the websites that are used on the web these days, and most of the ones that are very highly functional, are some form of dynamic web pages. Now, the last component that we're going to talk about before we get into talking about ASP.NET is the database component. And I'll draw it like this, which is meant to represent old-fashioned disk drives. And this is a database. So I'm the client. I go into Google. I type in that I want to search for ASP.NET. All right, so my request goes over along with the data that I'm searching for ASP.NET. It goes to the internet, which is represented like a cloud because we don't know the details of how it gets there. We just know it gets there. All right, it makes it to Google's server. Well, the program's not going to have, the program that it runs on the server doesn't have all the websites in the world built into that program, right? Into that page. That doesn't really make sense. What makes more sense is that there's a database that contains the websites that are indexed by Google. And, I can't pretend to say I have any idea at all how that works, right? But I can conceptually say, yeah, it's stored in a database somehow. If you know how the Google algorithm works to access that database, if you know and understand that, then drop this class, go out to San Francisco and get yourself a job, all right? Because it's very difficult, and that's their bread and butter. That's how they got in the position they are, is they did that bit better than anyone else at the time, all right? And that's what built them sort of almost, dare I say, a monopoly in searches. But at any rate, I am smart enough to know that somewhere in there is a database, right? You go to Amazon and you search for boots, for example. You find the boots that you want, you click that. All that product information about the boots, the price, reviews, shipping information, all that stuff is contained in a database. So with server-side scripting, a lot of the work is done on the server side. The work that's done also is the work of creating a web page. Client-side scripting pretty much handles manipulating pages that have already been created. Like you put a mouse over effect, or you, I don't know, the Google predictive search, where you type in a few letters and you get a list of words. All that probably deals with JavaScript. But this functionality is the functionality for actually creating the page in the first place. It's important to keep that distinction in mind. All right. I'm going to ask a question. Could the database access be done versus via client-side scripting? Could it be done via client-side scripting? I don't know if I can say it. Could you do database? The way I have this drawn now is the server that interacts with the database. Could the client interact with the database? Okay. Okay, that's fair. Now, let's think about that, because can it do it and is it a good idea are two different questions, right? Could it do it? I don't know, probably. All right. Could you write web pages? Maybe. I don't know. I've never tried to do it because it's a horrifically bad idea to do that. Why? Because you don't want to give up that security. You don't want to let the clients, the web pages that get sent to the client, know how to connect to your database. That's an open door for hackers to go in and manipulate it, right? So if you could do it, you'd have to somehow tell the client what the credentials were for that database, right? You'd also have to ensure that the client had certain software installed, right? Because not every program could read databases, right? Browsers don't understand databases. You need some program to read the database. So yeah, well, there might be some configuration where that would be theoretically possible. Is definitely a bad idea. You want that aspect of it to have control over. Therefore, this is on the server, and you secure this aspect of it. You don't have to worry about this aspect of it. You make sure that connection is secure and that no one else can connect to the database, right? I don't know. I'm hoping I explained that right. The final answer is you would never want to do that. So whether it's possible or not really doesn't matter. All right. You want the control of having only the server have access to it. This is an interesting situation though, because actually, in this case, I lied a little on the diagram. There actually is another machine here called the database server that controls the access to the database. And ironically, in that case, the web server is the client and the database server is the server. So whether you say a machine's a client or server depends on what interaction you're talking about. So a machine can be a web server and yet be a client to the database server. Now, you really only have one choice on the client side of how to write your code, and that is with JavaScript. You have a bunch of choices to how to write the code on the server side. right? PHP, Python, Ruby on Rails, JSP, Java servlets, Node.js, all the JavaScript frameworks that exist. All these things can be used to write server-side code, along with what we're going to be talking about in this class, and that is ASP.NET. All right. What is ASP.NET? ASP stands for Active Server Pages. It's kind of a throwback to how ASP pages were originally. Original ASP pages were called ASP pages, and they were active server pages. In other words, they weren't just static web pages. They were active on the server, meaning they did something. They took some kind of action. All right. Let's pull up a definition of ASP.NET. All right. A developer platform. Sometimes terminology is essential for understanding these things and being able to communicate. When we talk about a platform, typically we mean not just one thing, but a bunch of things. The platform, there's a bunch of components to it. Made up of tools, like for example, Visual Studio, programming languages, and libraries for building many different types of applications. ASP.NET extends the .NET developers platform with tools and libraries specific for building web apps. Let's see what Dig Deeper says. Why am I doing this? This is part of your first homework assignment. Let me hit the back button. In a nutshell, ASP.NET is Microsoft's solution to the dynamic database-driven website. Now, dynamic pages are not always database-driven, but usually they are. Very often they are. All right, because the whole point of it is to write a template and fill it in with data from a database. So that's ASP.NET. ASP.NET contains a list of programming languages or a series of programming languages. And the one that we're going to cover is C#. I think you've all had the intro to C#, right? And it's a language that you should be somewhat familiar with. However, one of the things that you're going to learn is using some of the tools and libraries, etc., that are specific to the web development. Because if you haven't done web programming, if you just had like the desktop application building, you probably haven't hit on any of the web tools and libraries. The word they didn't use here is a framework. I think they put those things in the word platform, tools, and libraries. So I think platform, tools, and libraries is synonymous with the way I would use the word framework. It gives you a jumping out point. You don't have to do everything from scratch. All right? Now, there's an old way of doing things that I won't put up here, but I'll mention. I think it's part of your assignment to find information. That's called ASP.NET Form. Web forms, I think. We are actually going to be using ASP.NET Core. And specifically, we're going to do code first. And specifically, we're going to write Razor Pages. Razor Pages is just a style of web pages that it's using a particular set of libraries and tools and components to create web. Now, what I'm going to do for the last 8 minutes or so of class is I'm going to go in and I'm going to create an empty Razor page application in ASP.NET. Now, you don't have to do this for your first lab. Your first lab can be plain old HTML if you want it to be. So don't worry about it if we just have a short time to do this example. You might want to, in lab, experiment with doing exactly what I'm going to do here and see if you can build upon it and extend it and so on. But I'm going to open up Visual Studio. They have 2019. I wonder if they have 2022. So. Go in here. Surprised it opened there, but I'm going to type in new project. Now, within ASP.NET, there's a bunch of projects you can create, a bunch of kinds of projects. Makes my head hurt sometimes looking at all these. Console apps using .NET Core. We're going to do ASP.NET for web applications. Pick that. Next. Our name, Web Application 1, that's good enough for what we're doing here. I'm going to put it on the desktop. I'm going to pick this one. ASP.NET Core Web App. Project template. Huh. Fine, empty. Something's not installed right in here. All right. I guess the last 5 minutes now of class, you're going to watch me do shadow puppets on the projector. No, I guess we'll end early because there's not much I can do. We'll leave it for next week. How about that? And I hope that it will be straightened out by then. All right, we'll see you up in lab.